All right, I quite like that timer. That's a new addition to the Brevity technical webinar series. So let's kickstart things. Welcome everyone. It's been a while since we have done a webinar actually, so it's good to be back. Webinar 8 today, we've got an exciting topic. We are going to be talking about the latest updates to the AWCI Code of Practice for the design, installation and seismic restraint of suspended ceilings. This is a document that was previously issued or released in 2015, and so it's been nearly 10 years, and there are some exciting updates in that draft document. So we hope this is going to be an insightful and useful webinar, particularly for subcontractors and installers in the commercial interior space and also suppliers. These webinars are fairly short and quick, so we try and aim for a 30-minute tops, and today it's going to be about 15 minutes of content, and then we will have 15 minutes of Q&A. Speaking of Q&A, if we can just jump to the next slide, I'm excited to introduce Slido again. So this is our interactive question and answer tool for today's webinar. Slido allows you to submit any question in real time, and you can upvote other questions. So this ensures that the most popular questions get answered first. Just visit the link on the screen there, the QR code, and you can start engaging, fire away with any questions. So we hope this makes it more interactive, and now it's time to get into the real part of it. So Matt, if we can just jump to the next slide, we have a bit of an overview here, but can you just start by, well, I need to introduce you actually. So Matt Bishop is our founder and visionary at Brevity, and I am Gye Simkin, our new business lead. So Matt, I know you've been heavily involved with the AWCI updates. Can you give the audience a quick update of what the Code of Practice is, and give a little teaser into some of these changes that we're going to likely see?
Yeah, for sure, Gye. If I remember right, you actually started the work on the Code of Practice and then handed it over to me about halfway through. With the Slido link there, if you missed it, it will come back at the Q&A point. So don't be too worried about stressing about getting that up on your phones right now. Okay, there's actually quite a lot of changes in this Code of Practice, and 15 minutes isn't enough time to go through all of them. In this particular webinar, I'm focusing on the process that you follow, the flowchart, and a couple of examples of that. One of the biggest changes is in how we've structured the design process flowchart, and how you choose whether or not it's a contractor-led design or an engineer-led design. So I'll be doing a couple of examples in that space. And then the other one that I've got time to focus on is the fixed sheet material suspended ceiling introduction, and what that is, and a little bit on how to use it. Then open Q&A. If we have a whole lot of questions about a whole lot of other stuff, well, we'll just have to do another webinar, Gye. All right, kicking off into some workflow examples, and I've got two for you. I've got a IL4 hospital and a IL2 apartment block. And this is the new flowchart that we've introduced on the left here in the new Code of Practice. And on the right-hand side here, I've got the IL level summary and the building parts level summary. The big point I want to make here is that project importance level and individual building element part categories are important to determine what you have to do for different ceilings. So I'm going to go back to that hospital drawing there, and have a look at a few different rooms. So what we have here is some surgery rooms. Ooh. Pressing the button on the wrong screen as I go through. Here we go. So we've got some surgery rooms in the middle of the hospital here. We've got a staff lounge off to the side here, and we've got a recovery and storage room there. Now going back, those are the three rooms that I'm focusing on here. Going back to the flowchart. The first thing, I see what I'm doing here. Right. The first thing is that this project is an IL4 project. So immediately when I'm determining the project importance level, I'm over here and I'm in the engineer only side of things. At a project level, there's a very little chance that a hospital design won't require engineer involvement for consent, coordination, and a whole lot of other things. So I'm starting off over here. But then as I go back into the different rooms themselves, thinking about the ceiling design, we've got three different ceiling types there. I'll just go back so as we remember. Let's look at the surgeries first. Now, the thing with the surgery rooms is that they have very strict operational continuity requirements. And that's what brings them in as P5 ceilings. Essentially what it means is that those rooms have to be able to be used after an earthquake, which means those ceilings have to have not fallen down, but for a surgery, have to be positive pressure proof as well. And that means no cracking in the edges or anything like that. Hence P5. And if we then go into the chart here, we see that a P5 ceiling needs specific engineering design. All right. You think you're following that so far, Joe?
I believe so.
Okay. Let's look at the P3 room, the one on the side here, the staff lounge. So that one's different. That one doesn't sit in the same category. That's sitting ceiling representing a hazard to individual life within the structure. Working through the ceiling type, that particular ceiling sits within our P1, P4 stage. It's a ULS design, which means a contractor-led design using a tool is possible to figure out what the scope of that particular ceiling is. However, being a hospital, we're over on this side for everything else, which means the consent requirements are going to pull us through into a PS1, into the consent application, into the PS3, PS4 process. There's one more room I wanted to pull out on that drawing too, and that's this P7 room here. And what is that? So a P7 room, it's a very small room. It's less than 7.5 kgs, and it's got less than 3 meters for the ceiling to fall. And it's also not necessary for continuing function. It's in a storeroom. It's not required for operational continuity. It's not got disproportional consequences. So it's a P7 ceiling, which means that particular ceiling doesn't need a seismic restraint design. So is that useful? Probably not on a project like this where every other room needs to be designed. However, it's again, the point between the project type and the ceiling building element design are that they are different. And in this particular situation, this recovery storage room is actually a P7 design. Okay, what do you think, Joe?
All right. So just to clarify on that, Matt, this project is a IL4.
Yep.
And we have different P classified ceilings. And so are we saying that we, using the flowchart, are some of these ceilings not going to actually need a PS1 technically? When you look at that flowchart, the PS1 is only on that far right-hand side, right?
Going back here.
Yeah.
These lines are different decision points. And try as we might, we can't really find a way of separating the project from the individual ceiling. So in this instance, when we're thinking about an IL4 project, because it's at the top here, you can see it's pretty hard to get out of the fact that you're going to need a PS1, which nicely represents how most projects will go. But if we're on the second decision here, and we're talking about the individual ceiling rooms, if you go strictly by the part category, that small ceiling in that storage room doesn't need a seismic restraint design. So if it was coming to the point of value engineering, say, as you're going through the project, and for whatever reason an engineer had spec'd 2 braces into that storage room, contractor would be well placed to argue the fact that maybe that was an over design. Probably was an over design. There's value to be had in remembering that there is a difference between the importance level of a project and the part category for individual ceilings.
That's super interesting, that one. And because I quite often see questions coming in, is a PS1 actually needed? And so you're saying it's best to start at the top there, the importance level for the project, and that can dictate it. Because looking at the other side, and I think you might be going into this zone, you might have a project that is importance level 2.
Yep.
And again, it could have similar P categories that cross over.
Yep, so that is actually the next example. So let's go there. I've accidentally flicked through it a couple of times. Here's an IL2 hotel design. It's pretty straightforward. It's got a whole set of repetitive rooms around the outside, and it's got a big atrium space in the middle. So again, looking at the flow chart from a project importance level, IL2, if all our settings are P1, P4, there's a grand chance that we'll be able to do contractor design. And depending on how the project itself is set up, we might not even need the PS1 stage. But then this also needs some thought. This is another decision process. Each one of these vertical bars, or horizontal bars, could change the lane that you're in. So regardless of what the building code says, regardless of what the code of practice says, if Tauranga City Council decides that they need a PS1 for the consent, well, then that's your consent requirements. Doesn't really matter what anybody else has said. If you want it to get through council quick, you're going to need the piece of paper. So just remembering that those council set requirements can change our lane even at this point. But let's say we're going through this particular project, and I'll pull out 2 different rooms on this one. 3 different rooms. A typical apartment ceiling. I've ignored the complexity with the internal walls there. I've got a corridor ceiling, and I've got an atrium feature ceiling that's sitting at the top of this atrium. Not sure quite what it is. I haven't seen the plans. It's some sort of funky architectural piece that's sitting up there, and it weighs tons. So I've labeled the ceilings in the apartment as P3, the ceilings in the corridor as P4, and the ceilings in the atrium space, the ceiling in the atrium space as P6. So we'll have a quick look at that. And what we have is we have a P3 apartment ceiling representing a hazard to individual life. We have a P4 corridor ceiling necessary for continuing function and evacuation. Essentially, if the corridor ceiling falls down, it's very hard to get out the corridor through the egress routes. We also notice that P3 and P4 have the same structure limit state and actually require the same design. So for the corridor and for the apartment room, they can be contractor-led designs. As long as the tool you're using can do corridor designs, of course, that's not always the case. And then the atrium ceiling, the heavy atrium ceiling, I've put as a P6, because if that thing falls down, it's not just going to disrupt one room, it's going to create issues all the way down that atrium, right down to the bottom in the cafe, say that's at the bottom there. So I've put that as a P6 category. Now, that for this project means that while we're over an IL2 at this point, we've got a P6 ceiling, which is going to jump into specific engineering design, which means that particular element is going to need to be engineered. It could then be engineered with a PS1, or it could be engineered as a specific design for that ceiling and incorporated into the contractor-led design at that point. You might be able to get out of that lane. And unsaid as we go through this is typically a costly lane, right? So from the contractor's perspective, we're doing what we can to understand at a granular level what's required on a ceiling by ceiling level. That's what we've put in the code. There we go. I bet you there's some good questions coming out of there.
That is great. I think there are already a few questions coming in. So Matt, just to clarify on the flow chart, like the P numbers, they come from a different standard, right? There's no changes. The P numbers,
correct.
They were in the previous AWCI. The main update here is it really that the flow chart is designed to be added to make this process more straightforward and more clarity? Is that correct?
Yeah, it's a good question. So the idea is that the idea was that we would have seismic grade categories within the code of practice, and we would use those to try and do this definition process as the interiors, as engineers and architects are becoming more involved with the interiors design side of things. We're reverting back to the standard definitions as they are in 1170. So these definitions are out of the 1170 series, and these part categories are from section 8 of 1170.5. So it's kind of taking it back to a common language, a little bit easier to discuss with other people in the industry.
Awesome. Well, that's the flow chart. I'm sure we're going to be getting some questions there that we can delve into deeper. You had another bullet point to discuss today. Let's jump into that.
Yeah, the fix typical example. So this has come from the lining manufacturers, essentially the plasterboard manufacturers, who are getting a lot of issues on projects with fixed float details and coordination issues with acoustic and fire details. Essentially, a floating plasterboard edge can't be fire rated. So, okay, cool, they're looking into that a bit further, and then the question gets asked, well, is it really floating? And when they do tests on the strength of this we've done that. Wrong page. When they do tests on this floating joint here, they find out that it doesn't float at all. And if they're following their standard square stop detail, they're actually getting more strength in that connection than they are out of our fixed connection. And that leads us to go, okay, these ceilings are effectively fixed. Always have been. And that seems to be counter to what 2785 is saying. So then once we have a close look at 2785, we find out that it doesn't actually say that you require fixed float detail. It says that you're required to seismically restrain your ceilings. And then it gives 4 typical examples inside 2785. So essentially what we've done here is added a typical example for a fixed perimeter restraint and then conditioned the heck out of it.
Yeah, cool. You raise a good point there with 2785, the suspended ceiling standard. Do you see this detail potentially being included in 2785 in the future? Or is this like a bit of a trial period coming up?
We'll see what happens. Standards don't change fast. So it makes a lot of sense. but it's only just been reviewed, so I wouldn't expect it to be incorporated into the standard for at least 5 years, probably more like 10. But like I say, there's nothing preventing a different typical example being used as long as the engineering backs up the use case.
Cool. And with the engineering, like where would you recommend, or where would we maybe not see a fixed suspended plasterboard ceiling being used?
Got a page of, you can see those constraints here on the typical example. Well, that'll be too small for anybody to see, to be fair. So here they are again in a little bit more detail, but still kind of overwhelming. Essentially, we're limiting this detail to projects where we know we don't have complex loading or importance level issues, to a specific mass, so we're not talking about heavy, to areas that don't exceed the natural expansion joint lengths or restrictions of plasterboard anyway, to systems that aren't braced, to systems that are suspended to manufacturer's guidelines, both in the suspension framing and the material linings, to walls that aren't too weak, to ceilings that aren't complex in the way they interact with the rest of the building. That's like long columns going up through floating ceilings or stuff like that. Who knows what's going on there? It really needs specific engineering design, and also to level ceilings. So essentially, we're limiting this detail to standard apartment plasterboard square stop ceilings and the like.
Yeah, cool. So I'm thinking, like, if I'm maybe an architect or a designer, this detail here can help with noise performance, make some of the fire details easier. And who do you think is going to be driving or making a push for, hey, on this project, let's do a fixed plasterboard ceiling detail?
Yeah, I think what's happening currently in the industry is that the fixed float detail markups hit the ground on site, and they're getting fixed anyway. If I had one personally a while back on a hotel job where it did become a raised coordination issue, and it's like we can't sign off our fire certs unless we fix it around the perimeters. And what's the bigger risk? Or at least that's what we were thinking at that point. And now we find out that the risk of, got to go back a bit. The fixed float detail is really important for grid and tile ceilings. And the reason it's important is that the grid is the structural member. The grid has to transfer the load from one side to the other. And if you're talking about a grid and the load as it goes right across the room, it's flexy. There's a little bit of movement in every splice joint, and that adds up over the way. And if you don't have a floating detail with a bit of movement, it's going to crash into the wall, it's going to buckle the T's, and the ceiling is going to collapse. There is so much evidence on that particular failure mode. But a sheet material line suspended ceiling is a whole nother deal, where the sheet material can be extremely structural, can take load in its own right. So when you expect it to float in a square stop corner, all of the load's going through the plasterboard still anyway. So the reason for the floating detail on a grid and tile ceiling is not there. When we think back to the Cordis fire detail that I was talking about, I don't think we made it any less resilient.
Yeah, great. For the sake of time, Matt, should we just pull up that Slido QR code just to make sure anyone can post some questions? Because I'm looking at that third one on the list there, quite relevant to what you were just saying. Someone has asked, so the fixed example would not be allowed with a shadow line perimeter detail. What's your thoughts on that?
I don't have data on in a shadow line, you're relying on the fixing between the plasterboard and the screws. And I know that plasterboard can be screwed off in a way that you can get strength through the plasterboard. That's a diaphragm sealing, essentially.
Mm-hmm.
For this particular approach, I'm not 100% sure on what the screw spacings is. So it's probably is allowable with the right screw spacings, which I couldn't tell you at this point. But it's a fairly common detail, so we should probably work on getting that one fixed too.
I feel like there's a detail there. I agree. Yeah, for a shadow line fix, that'd be pretty cool.
Yep.
Hopefully the audience here, the QR code is on the top left of the screen there if anyone wants to take a photo. There are some more questions coming on, which is great. Let's have a look at the top one. Who decides which ceilings are P1, P2, P3, etc.?
Yeah, that's a good question. At the moment, it's buried into the engineering process. You probably don't even know that there's part components unless you're following through 1170 and doing that part category process. It can be contentious. The big breaks between P1 to P4 and then 5 and 6 will change the design quite a lot, and they are quite obvious. So if you're thinking about the first 4 categories, you're thinking about essentially all apartment and corridor type details, and then P5 surgery rooms, and P6 something that's going to fall on a kindergarten or take out a different system or something like that. Like they're quite extreme jumps between those. But this is the same as the third question down there. Does the importance level rating apply to the whole building? Depends. Like we've had projects where a building is categorized as IL3 apart from 2 floors which they've decided are IL4. And I always thought that was a bit nutty. How does the earthquake know that these floors are IL3 and this floor is IL4? Like it didn't make sense, but that's what got written into the contract documents. So the answer is sometimes. But it's these are the important thing here is that these parameters should be settled in the contract documents in the design specification, so everybody starts on the same page. And question 4 there, while we're on the importance levels, yeah, it's supposed to be the entire building. That's my understanding too. I'm just saying I have seen it applied in different ways. Probably not right, but that's what got built.
Yeah, that's in response to the bottom one on the screen there?
Yeah.
Yeah. Cool. Why don't we just do the third one there while we're on the fix? So are you presenting this to architects so that the P50 detail, so that is the shadow line detail, right, can go away?
Yes, let's. Not today though. Well, unless we've got architects on here, I suppose. But, yeah, maybe. For sure. We need to work on this. Yes.
Yeah, it's it could be one of those. It can't be done because it's not how it's been done in the past, and some architects definitely don't like changing the way it's been done. So it will be interesting to present that to architects as a new option. With the top question there, Matt, is there a code of practice for steel studs?
No. There is a AWCI has the partitions code of practice that's there. But from the standards point of view, the only time steel stud partitions are mentioned are in the 2785 standard. As an appendix that says, make sure you don't put too much load on your partitions, pretty much.
Yeah.
We design partitions to 4600, the cold form steel standard, and 1170 directly, in the absence of having anything more specific.
Yeah, cool. It's a good plug there to refer to one of our earlier webinars where we talked about the compliance code pathways for suspended ceilings and partitions, for just how partitions are designed in New Zealand. There's another couple questions here, so keep firing them in. Matt and I will stay on answering questions for a while.
Yeah.
So if we isolated the partitions from structural movement, would that simplify ceiling design? Like we've seen, there are systems out there that do isolate the partitions from structural movement. So yeah, what's your take on that, Matt?
It will certainly reduce damage. It reduces any chances of superstructure pushing. Essentially, superstructure can't push the interiors around if you do that. So would it simplify it? From a designer's perspective, you're changing a traditional design approach to something else, which means that you're probably simplifying design, increasing resilience, and increasing the complexity around coordination as you explain to everybody what it is that you've done. But that could be a point in time thing as well.
Yeah, like from the recent AWCI conference in Wellington a few weeks back, there were some cool systems that were being thrown around there, and I think it's just showing where the industry is moving with some bespoke solutions that are going to become more prevalent. So,
yeah, for sure, especially with taller, bendier buildings going up, which is the way city design is going.
Cool, we'll tick that one off and move to the next one. Areas less than 144 square meters. Can we proceed with fixed method as the first method of installation?
If I was boss of all projects, I would say yes. However, not being boss of all projects, I'd say that there's good engineering precedent for a fixed method. Being new, I would be making sure that I'm not going counter to other stakeholders in the design workflow, though.
Yeah, I imagine that's coming from an installer or a subcontractor. Would you recommend, if I was an installer working on a project that is still being designed, well, talk to the project team, I guess.
Yeah, for sure, and we will definitely proceed with the fixed design on a 4 square.
Yeah, cool. If you need to run, please don't feel like we're holding you back here.
For sure.
Go for it, Matt.
It's all going to be recorded on the web if you want to catch up with whatever you missed.
You beat me to that point. So yeah, we'll keep going for another few minutes if questions are still rolling in. It's great to answer these live. Are you in dialogue with regional councils? I wonder if this is coming from a AWCI perspective with these updates, or Brevity as engineers. So Matt, maybe you can answer both there.
Yeah, for sure. We are planning from the AWCI point of view to do regional roadshows, and we can definitely pick up the councils as part of that. They do operational and technical catch-ups at certain times of the year. And then personally, less so on a councils are funny. Like if we're talking about a certain project, it's extremely hard to get a good dialogue, because they're essentially acting as police folk, and they're non-receptive to anything we're doing at that point. We have to catch them before that in a more general space, and our dialogue is going to be around not just the AWCI work, but also through the manufacturers that are helping us with these as well. So hopefully we'll hit them from various different angles and get a bit of sense, get some movement there.
Sounds promising. Okay, well, 1:35. I reckon we maybe call it there. And like Matt said, this has been recorded and it will go up on our website in the next hour or so. And if anyone does have any good suggestions or ideas for future webinars, do get in touch, because we'd prefer to talk on a topic that is industry related.
Yeah.
Do you have any final comments, Matt, before we?
No. Okay. Thank you, Joy. Thank you, everybody, for tuning in. We'll see you all next time.